So today we discuss about the topic kinematics of fluid flow. First, the definition of kinematics. What is kinematics? Kinematics is the branch of science which deals with the motion of particles without considering the forces causing the motion. That means our study should be concentrated on determining the fluid characteristics, that is velocity, acceleration, pressure, density, etc., without considering the forces which causing the motion of the fluid particle. Okay. Now there is two methods, that is one is Lagrangian method and another is Eulerian method. Okay. These two methods is used for studying of fluid motion. In Lagrangian method, a single fluid particle is followed during its motion and its velocity, acceleration, density, etc. are described. Okay. And the second method, that is the Eulerian method. In case of Eulerian method, the fluid properties, that is velocity, acceleration, pressure, density, etc. are described at a point in a flow field. Okay. The Eulerian method is commonly used in fluid mechanics. Okay. Now, types of flow. First, steady and unsteady flow. In steady flow, fluid characteristics, that is velocity, pressure, density, etc. at a point do not change with time. Okay. So for steady flow, del V del T is equal to 0 at a coordinate x0, y0, z0. Okay. Similarly, the density should be constant, so the rate of change of density is equal to 0. So del rho by del T is equal to 0 at a coordinate x0, y0, z0. Similarly, the pressure should be constant, so del P del T is equal to 0 at a coordinate x0, y0, z0. And for unsteady flow, del V del T is not equal to 0 at a certain coordinate, that is x0, y0, z0, and del P del T, that should be not equal to 0. Similarly, del P del T is not equal to 0. Okay. So for steady flow, the fluid characteristics, that is the velocity, pressure, density at a point do not change with time. And for case of unsteady flow, the fluid characteristics, that is velocity, pressure, density, etc. at a point changes with respect to time. So now consider a fluid is flow through a pipe. Okay. So this is a pipe, that is fluid is flowing in this direction. Now this is the section 1. Okay. And this is the section 2. Okay. Suppose at section 1 the velocity is 10 meter per second. As I draw, the passage is decreasing towards its motion, towards the direction of its motion. So at section 2 the velocity is increased, that is 15 meter per second. Okay. So it is V1, it is V2. Okay. So if the time is changed and at section 1 the velocity is constant, that is 10 meter per second, so the flow should be called as steady flow. Similarly, for the case of section 2, as time goes, the velocity at section 2 is constant, that is 15 meter per second. So from the definition it is said that in steady flow the fluid characteristics, that is the velocity, pressure, density, etc. at a point do not change with time. So as the time goes, the velocity at section 1 is not changed velocity at section 1 is constant, and similarly the velocity at section 2 is also constant, but the velocity at section 1 and 2 is different, but it should be called a steady flow because at any point the velocity is constant over the time. Okay, so this is the example of steady flow. And if the changing with time, the velocity, suppose at t1, at time t1 the velocity is 10 meter per second at section 1 and velocity is 15 meter per second at section 2. Suppose the time has changed, now the time is t2, then velocity at section 1 is 15 meter per second and velocity at 2 is 20 meter per second. So it should be called a unsteady flow because with the changes of time the fluid characteristics are changes at a certain coordinate. Okay, next, uniform and non-uniform flow. Uniform flow is defined as that type of flow in which the velocity at any given time doesn't change with respect to space. Okay, so it means with change of space the velocity is constant. Okay, so space is denoted by s. For uniform flow, del v del s is equal to 0, means the change of velocity with respect to space is 0 at t equal to constant, means at a certain instant. Okay, the definition is clear. Uniform flow is defined as the type of flow in which the velocity at any given time means at any instant does not change with respect to space. Suppose a fluid is flowing through a pipe. Okay, now this is the section 1 and this is the section 2. Now at section 1 the velocity is 10 meter per second and velocity at section 2 that is also 10 meter per second at time t1. Okay, so at time t1 means at a instant the velocity of section 1 and section 2 is same. So that is the example of a uniform flow. Suppose the time is changed and the velocity at time t2, velocity 1 at section 1 has changed to 15 meter second. Similarly at time t2 the velocity also changed at section 2, that is 15 meter per second. So it is the example of uniform flow. That means at a instant means at a specific time the velocity is constant with respect to its spaces. Okay, if this coordinate is changed but the velocity is constant at any instant. Okay, so it is an example of uniform flow. And for case of non-uniform flow, the velocity is not constant throughout the space at any instant. So it is written as del v del s, that means rate of change of velocity with respect to changes of velocity with respect to space, that is not equal to 0 at any instant, that so it is written as t equal to constant. Okay.